In this video, we will be talking about the Williamson synthesis of an aryl ether.
The goal of this lab is pursuing an acid-base reaction following by an SN2 reaction to create an aryl ether. Our first step consists of refluxing the mixture of reagents, specifically the phenol, sodium hydroxide, and ethanol.
The materials for this experiment are a Bunsen burner with a ceramic pad just placed about 2 inches above it, as well as a round bottom flask which can be 50 or 100 milliliters. And inside this flask we have the reagent mixture with a couple boiling chips. The flask is slightly above the pad held by a snug clamp.
In the greased opening of the round bottom flask, you want a condenser held by a loose clamp about 3/4 the way up. On this opening of the condenser, you want the cool water coming in, and on this opening, you want the cool water coming out.
As you can see in this mechanism, we start with our phenol, which is 3-hydroxymethylphenol, and the OH attacks from the NaOH to attack this hydrogen. And now the phenol will look like this, and then the alkyl halide, 1-bromo-3-pentene, comes into play.
The halide acts as a leaving group, and the negatively charged oxygen on the phenol attaches itself to the remainder of the alkyl halide. Now we have 3,2-butene, 1-ioxyl benzene methanol.
When we do this reaction, we will first want to carefully weigh our reactants on a tiered scale, being sure to record to 3 decimal places. We will then place them all in the 50 to 100 milliliter round bottom flask. Our reactants consist of the phenol, ethanol, and the sodium hydroxide in the reaction vessel. And we can't forget the boiling chips.
After the reactants have been placed in the vessel and the Bunsen burner has been lit, carefully examine the reaction. The time for refluxing period begins after noticing the first few droplets of liquid entering back into the round bottom flask.
Once the reaction has refluxed for 15 minutes, let the reaction cool to room temperature by removing the ceramic pad. Once it's cool to touch, remove the condenser and carefully add the alkyl halide with a pass-through pipette. It is very important to ensure there is no grease that accidentally enters the flask. Then we can reflux for 40 minutes, making sure to start the timer at the appropriate moment.
In this reaction, you will want to avoid having excess sodium hydroxide in the reaction mixture, otherwise the nucleophilic attack of the phenolate to the alkyl halide will not happen.
A concern that you might have is what is the appropriate amount of sodium hydroxide during the workup of the Williamson? There needs to be an excess of sodium hydroxide to ensure that the base deprotonates the phenol. This ensures that all the phenol has become the phenolate.
To determine an appropriate reflux period, a TLC plate test can be used during refluxing to identify which compounds are present at that moment of the reaction. After applying your sample to the plate and waiting the appropriate time, you can examine your results. Multiple spots would mean a larger reflux period is needed. If the test comes back with 1 spot, a shorter period may be needed. The TLC plate is useful as it allows us to determine the purity of the sample by identifying the compounds that are present.